Hi everyone, welcome back. In this video, we will be discussing about the fastest way of dealing with polynomials. So first, we need to learn how to draw the approximate graph of a polynomial. So let's say we have some polynomial like f of x is equal to x minus 3 times x minus 2 times x plus 1. So first, we need to look at this polynomial and decide how many x-intercepts are there. So x-intercepts essentially means when will this graph across the x-axis. So let's pretend that this axis right there is a x-axis. Then we will see that when x is equal to 3, 2, and negative 1, this function will be 0. Therefore, we will have 3 x-intercepts at x equal to 3, 2, and negative 1. So we will put them onto the x-axis respectively. Now it's the fun part. So we first look at the leading coefficient right here. We need to determine the sign of it. So right now it's a positive. So we start above the x-axis right here. So we start from here, and when we come to 3, we look at this term x minus 3, and the multiplicity, which is the exponent, the power of this specific term, and in this case it is 1. So if it is an odd multiplicity, we will directly go through. And we curve up, we come to 2, we look at this x minus 2, the multiplicity is still 1, so we cross, and we look at x plus 1, it is still 1, so we cross down. So this will be an approximate graph of the polynomial f of x is equal to x minus 3 times x minus 2 times x plus 1. Next, we will look at a relatively more complicated example. F of x is equal to x minus 5 to the power of 3, x minus 2 to the power of 4, x plus 3 to the power of 2. So we have encountered some more irregular powers right here, but the x-intercepts are still determined using the same methods. So we can see that when x is equal to 5, 2, and negative 3, this function will be 0. So these 3 will be the x-intercepts. And we look at the leading coefficient. What about, let's make it negative right here. So if it is negative, we will start below the x-axis, but still on the right end. So we go from here, we come to 5, and we'll look at the leading coefficient, the power, sorry, it is a 3, so it will go through, but this time we will approach the x-axis and then go through, and then curve down, and we come to 2. So x minus 2, we have an even power. That means this curve will bounce up and at negative 3, the power is still an even power, which means it will bounce again. So this will be the approximate graph of this polynomial. So after we learn how to draw an approximate graph of a polynomial, we will be looking at how to solve for a polynomial inequality, because this will be a direct application of this approximate graph we just drew. So let's say we have a inequality like f of x is equal to x. Let's just use this example. Let's say the f of x, which is referring to this f of x, is greater than 0. So to solve this, we just need to look at this graph and to determine which areas are above the x-axis, because any function values above the x-axis will be greater than 0. So we will see that any values in this general area will be above the x-axis, this area, this area. So essentially we are saying when x is from negative infinity to negative 3, union, which means and, negative 3 to 2, and 2 to 5. So we have 3 areas of values or x values that we can take to make this function value greater than 0. So let's look at a full example run through. So we have f of x is equal to positive x minus 3 squared x plus 1 times x minus 3 plus 3. So we will have, and the question is to solve the intervals for x where f of x is less than or equal to 0. So first, we still draw an approximate graph for this polynomial. So we look at this, we will first determine the x-intercepts. So the 3 x-intercepts will be x is equal to 3, x is equal to negative 1, and x is equal to negative 3. And since the leading coefficient is positive, we will start from the top right corner. We come to 3, we look at x minus 3 to determine its square, its even power, it means it will bounce. Negative 1 corresponds to the term x plus 1, and we will see that the power is 1, so we'll go through. For negative 3, the power is 1, we will also go through. So this will be the approximate graph for this polynomial. We're looking for the general areas where f of x is less than or equal to 0. And we are looking for anything that's below the x-axis. And we will find that only this area is below the x-axis and included in this function is below the curve. Which means when x is belong to the interval negative 3 to negative 1, or we can say the x is less than or equal to negative 3, or greater than or equal to negative 3 and less than or equal to negative 1. Be careful that we're using the square bracket and the less than or equal to and greater than equal to, because in the condition of the question, it is less than or equal to 0. And the value of negative 3 and negative 0 will make the function value 0, satisfying the condition of the question. So this is literally the fastest way of dealing with polynomials, drawing the approximate graph, and doing polynomial inequalities. Thank you for watching.